is our first lecture for this subject in S164. The name of the subject is about the strength of materials. Okay, so or in other textbook, uh, this is called the mechanics of deformable bodies. Okay, so for the background of this subject, it is under the engineering mechanics. Okay, so engineering mechanics is breakdown into two components. You have the mechanics of solids and mechanics of liquid fluids. Under the mechanics of solids, you have the mechanics of rigid bodies. Rigid, by the term itself, rigid meaning it does not deform in shape or does not change its properties within the body. Okay. So under that one, you have the statics and dynamics. So this statics is ENS 161 and dynamics is ENS 162. So the other subtopic of mechanics of solids is the mechanics of deformable bodies. So in the subject, the bodies that are being studied already has deformations, no? Ma-deform na siya. So it is important that we also learn this subject because using this the concepts that are makuha na to din yung subject, you'll be able to properly size your design, okay? And also, you will be able to have confidence that your design will not fail. So, isa na no, sa mga main importance ng subject to be able to design properly your components. Mga components will not break or fail. Okay, and mechanics of fluids is ENS 165. So, wala pa mo ani. So, kaning subject also will be dealing about fluids, liquids or gases. What is the effect if you apply forces on fluids? So, sa studyhan ninyo in ENS 165. Okay, so in this subject, we have two reference book. Okay, you have the Strength of Materials by Andrew Peitel and Ferdinand Singer. And also, pwede po natin igamiton yung Mechanics of Materials by R.C. Heveler. Okay, so for this lecture, kaniyang gamiton the book by Heveler. Okay, so in chapter 1, we have some introductory concepts and also what are the concepts yung kinanglan nato, no? For this subject. First is you must know, you must already finish your ENS 161 or statics of rigid bodies. Okay, so unsa may na-learn yan sa statics of rigid bodies? Okay, so in statics of rigid bodies, you must be familiar with drawing the free body diagram, no? Forces, knowing the forces that acts on the body, the type of reactions, support, as well as to establish equilibrium for a certain object, no, to determine whether it is in equilibrium or not. Okay, and also in ENS 161, you all now have, okay, so I'll just show you no mga things nga you will be needed in this subject. First is familiarize kanino kani mga types of support, connection, and then the corresponding forces. Kay gamiton na also in the subject. Establishing the equations of equilibrium, summation of forces and moment, determining the support and reaction. Okay? So, ato ra ni siyang gilabyan because na naman sa inyo ang N is 161 and also kung nakalimot na mo kindly review. Okay? Sample, this one. How do you get the reaction? No, this is a cantilever beam. No? Kung saan man mo pagkuha ng moment and the support nga kuan dere, reactive forces. Okay, so you must apply summation of forces and then summation of moments. So, nasa dere, okay, apply and then makuha na nimo ang mga forces. Okay, for this one as well. So, kindly review your ENS 161. Okay, we'll now proceed with our first topic, which is about simple stresses. Okay? So, what is stress? Kano sa amin siya mo? Anong naa may stress? Okay? Okay, so, well, in figure 1-9, you have a body. And then, kaning nga body, ana kay forces 1 and 2. Okay? So, ang equivalent na forces ana niya karon is this one. You have the resultant force and you have also the moment. Okay? So, kani nga forces is since gi-act ni sa imo ang imo ning gi-subject diri sa body nimo, para ma-establish ang equilibrium, there must be a reactive force, no? Na ay dapat mo balance anang a force. So, mo na ang mga forces sa imong support, sa imong kuan, depende no sa type sa support nimo. Now, katong reactive forces mo to mo create og stress sa imo ang material. Okay? Mo to siya. So, if we will cut this object, okay, kung cut nato na siya ni ani, okay, we will find out that you have this one. What is this one? Sigma y, tau yz, and tau yx. Okay, so, unsa man ni sila? This are what you call the stresses nga na-experience sa imo ang object, no? Because of the kani mga internal nga reactions. No? Kaya di ba, pag subject sa imo ang force, mo create ang imong body of reactive forces. So, kato nga mga internal force, mo to yung nag-cause aning imo ang stresses. Okay, so we have two types of stress, the normal stress and the shear stress. So, kung yung tag normal, so meaning perpendicular sa imo ang surface area. Sample, this one, kaning area, this is the normal stress. And also, kung parallel sa area nimo, mo ni siya tau yx and tau yz. This is what you call the shear stresses. So, ang pagbasa ani niya, kaning notation ani niya, yz, pasabot ana is, this is the ang kaning sample. Sample no, this is your coordinate system x, y, z. Okay? Ang imo ang area is perpendicular sa z. Kani. Kaning area, no? So mo ni siya normal stress. So mo na siya nga kani unsay tawag ani nga stress parallel man parallel sa imong area. So these are your stresses. So ang kanang z pasabot ana ang plane na siya nga perpendicular sa imong ang z. Ang x ang direction sa imong ang stress. So tau z x kani kay tau z y. Okay? So these are just your shear stresses. So kung itap magkuha ta og small cube dire sa imo ang surface, mao ni siya kani. So what are the stresses present in this cube? So mao na ni siya. Naa kay pila ka side ani? 6 and every side na kay tulo ka stress. Normal and shear stresses. Okay, so we will expound sa normal stresses. So, ang normal stress nimo is, again, from the word itself, it's normal, meaning perpendicular sa imong area. No? So, we have two types of normal stresses. We have the tensile stress and the tensile stress and the compressive stress. Okay? So, meaning, tensile meaning pabira siya, no? Gibira nimo ang material. Compressive stress, this is the stress nga ma-experience imong body kung imong i-compress ang imong ang material. Okay? Okay, this is your equation for your normal stress. Okay, you have sigma is equal to P, which is the force over area. Okay? So, kaning stress nimo, normally, mao po na siya ang nag-represent sa strength mong material, no? Meaning, kung dako og stress nga makaya ang imo ang material, meaning mas kusgan siya. No? So, how much force can it resist, no, for a given area? Okay, so ang kaning equation is thus the average nga normal stress. Average meaning ang imong force man gud, no, kung naa kay force nga gi-apply, di man gud na sa ma-equal, no, sa isa ka area, maglahi-lahi gyud na siya. No, so mo nang maglahi-lahi na siya because sometimes ang imong material kay dili homogeneous ang iyang composition, no? Or ang iyang kuan siya ani anisotropic material, ang properties dili pareha in the same in certain direction. So mao na siya nga this is just the average, no? Average normal stress. So sa dali ra kay na siya i-apply. You have the area, no? First is tanaw nimo ang area. Kaning force is perpendicular ani nga area. So this is normal stress. And then unsa man siya, gi-elongate ba niya ang imong material or gi-compress? Kung gi-compress, this is compressive stress. Kung mura og gibinat, this is tensile stress. So ana ra na siya. Okay? Okay. Now we will proceed with the average shear stress. Now, kano sa man mo occur ning shear stress, no? Again, shear stress acts in the plane that is ang imong force is parallel sa imong area. Example kani nga setup, you have block B and D, ang ibabaw ana niya na ay kani nga block A. And then imo ning giduot unsay mahitabo, ang ma-stress nga area is kani duha, no? So ang imong force is parallel ani nga area, so this is shear stress. Okay, so again ang equation ani niya is V. Ang V is just the reaction na force, V over A, or this is just force over area. So the same raman of equation ang normal stress and shear stress. Okay, so let's have this example. So we have a composite bar, meaning it is composed of different materials. Okay, consists of aluminum section, this one, rigidly fastened between a bronze section and a steel section. Actual loads are applied at the positions indicated. Now the problem is determine the stress in each section. Okay, so we are asked to find the stresses in this section, this one, and this steel section. Okay, so how are we tackle this problem? Okay, so first, let's add the forces horizontally if it's resulted to equilibrium. Okay, so you have 4,000 and 7,000 going to the left, and you have 9,000 and 2,000 going to the right. So this just cancel out each other. Okay. Okay. So first is we need to cut a certain section in this one. So we will have this free body diagram. Okay. Section 1. We have 4,000 pound. Okay. So what is the reaction force? This one. You have F sub VR, okay, which is equal to, if we apply the summation of forces along X, FVR is just 4,000 pound. Okay, 4,000 pound. Now, therefore, since we have the force and the area, we can now get the stress in the bronze section. This is just 4,000 pound over 1.2 square inches. So this is just equal to 3,330 PSI. Okay? 3,330 PSI. Okay, so what is this type of stress? Is it tension or compression? Since it tries to elongate the bar, so this is in tension. Okay? Okay, so next we will cut a section around here. Okay? So we will have this section. Okay? So what are the forces involved? You have the 4,000, 9,000 pound, and the reaction force. So wala pa ta kabalo no whether paana ni siya or paana. May bawa na to na later on when we add the forces. So kung makita nato diri mas dako man ang pa-right, so probably this is a reaction force. So posible pa ano ni siya F force in the aluminum. Okay? So if we add the forces along X, so you have 9,000 minus 4,000, so this is 5,000 pounds going to the left. Okay? Therefore, the stress in the aluminum is just 5,000 pounds over 1.8 square inches. So this is 2,780 psi. Okay, so since this tries to compress the aluminum section, so compression. Okay. Lastly, we will cut section around here. So, natin do ka section. Pwede na to i-consider ang left and the right. Okay, no? So, kung ang left ito i-consider, gamayin lang na akong drawing. Natay something in ani. Okay, you have 4,000, 4,000, and then 9,000, 2,000, and a reaction force around here. F steel. Nganong to the left man? Assumption na lang nato ni, no? Pero kung tanawon po nimo, dapat yaman ning i-counteract ning whichever is dako nga force dire niya. Mas dako man ang pa-right. So, probably pa-left na siya. So, this kung magkuha tayo summation of forces along X, makuha na ito nga to the left din siya. So, 11,000 minus 4 is 7,000 pound. Okay? So, the stress in the steel is the 7,000 divided by 1.6. So, this is just 4,380 psi or pound per square inches. This is in compression. Okay? Again, pwede mo consider ang kaning right. So, ano na lang ni. So, isa ra ka buok, dali ra kayo. Same answer kaya po mo makuha. Okay? So, hopefully you get the idea on how to get the stresses in a section. So, makikita ninyo na kag-apply nga force, ang nag-create sa stress sa imong material is the reaction forces, no? Kaya mo man na ang mo resist go sa gi-apply nimo nga forces. So, mo na ang gigamit. Okay? Let's have another example, and we have this block W. The block of weight W in figure 1-10 hangs from the pin at A. So this is the pin. The bars AB and AC, so we have this one, AB and AC are pinned to support at B and C. The areas are 800 mm squared for AB and 400 mm squared for AC. Neglecting the weights of the bars, determine the maximum safe value of W if the stress in AB is limited to 100 10 megapascal and that in AC to 120 megapascal. Okay, so we are asked to find the maximum weight so that bars AB and AC will not fail. Okay, so given ang area and the maximum stress, allowable stress that AB and AC can handle. Okay, so first is draw the free body diagram. So you have this free body diagram. You have force AB and force AC and the weight. Okay, so unsay unang buhaton nato ani? First is we apply the Newton's first law, which is the summation of forces. Okay, must be equal to 0. So you have summation of forces along x is equal to 0 and summation of forces along y is equal to 0. So you have PAB, okay, positive to the right. So you have PAC cosine 60 minus PAB cosine 40 is equal to 0. And for the vertical axis, you have PAC sine 60 plus PAB sine 40 minus weight is equal to 0. Okay? Now, if you need this equation, no? The forces in terms of weight. Okay, so yun sa ni pagkuha is from this first equation, you get the relationship between PAC and PAB. Okay? Okay, so we will solve this one. Okay, so let's draw the free body diagram. You have PAB, and you have PAC 60 degrees, one is 40 degrees, and you have the weight. Okay, applying the Newton's first law of motion, we have PAC cosine 60 minus PAB cosine 40 is equal to 0. Okay, and along the y-axis you have PAC sine 60 plus PAB sine 40 minus weight is equal to 0. Okay, if we get the relationship between PAB and PAC, this would result to PAC is just equal to 1.53209 PAB. Okay, and then we will substitute this one here. Okay, so makuha ni mga na equation would be in terms of W. So we'll get this one, PAB is equal to 0.508 W, and then this one, when you substitute there, you will get PAC is equal to 0.778 W. Okay? Okay. So, the next step that you'll get is ano man kinahanglan man nga kuhaon nato ning duha ka equation, because kung kanilang imong kuhaon, di mo ni kuhaon isa, makakuha kag value sa W nga pwede sa AB pero mo fail sa AC, no? Meaning nahilahi man sila og strength good, allowable nga kuha nila strength. So ano kinahanglan nato ni kuhaon ning duha. Okay, And then, using this equation, we will get W, okay? So, ang pini mo, okay, for AB. Okay, for AB, we have sigma. Ang sigma AB? PAB over area AB. Okay? Ang strength na given sa AB is 110. 110 megapascal. 110 megapascal. Okay? So, ang 1 megapascal is just equivalent to 1 Newton equal to 1 times 10 to the 6 Newton per m squared, right? Or, this is just equivalent to 1 Newton per mm squared. Kung per mm squared. No, so, na yung mga times nga kanin mas dali ni gamiton kay ang area nimo is in mm squared. So, ang itabuan ni PAB is 0.508 W over okay, ito na lang yung indes na ni MPA ha. Newton per mm squared over ang area sa imong AB is 800 mm squared. So, cancel na lang ng imong mm. Therefore, ang weight ang makuha naman sa AB is ilaman 173 kilonewton. Newton man no? 173,000 makuha ni Manny. Okay? I-round off na siya. Now, wala na yung irasan. Irasan ha. For AC, you have sigma AC PAC over area AC. You have ang stress sa AC is given by 120 megapascal. PAC is 0.778 W over 400. Okay, cancel. Therefore, ang weight na makuha niya is 61.7 kilonewton. Okay. Okay, duha ka weight ang nakuha na to. The question is, which of these two is the allowable weight? Which of these two? Kani or kani? Okay, so unsay pasabot ani? Ang pasabot ani, ang imong bar AC is only capable of carrying 61.7. Mas gamay siya og kaya nga makarry compare sa AB. So meaning, ang mas gamay kani atong bilion para dili mo fail ang AC. Kaya kung ang 173 mong ibutang diri sa pa unsay metabo sa AC nimo, posible maputol, hey? Man niya kaya 61.7 naman niya kaya. So this is the answer. So this is the importance of knowing the subject because in designing your structures, makabalo ka nga, more din ang allowable na weight. So, dili mo palabian para di ma-fail. Okay? And later, we will have an example also for solving shearing stress. Okay, so let's take this example for analyzing members that are experiencing shear stresses. Okay, so determine the average shear stress in the 20 millimeter diameter pin at A and the 30 millimeter diameter pin at B that support the beam in this figure. Okay, so for this example, we'll all same remaining process, no, pagkuha sa shear stress A and B. So we'll just solve for the shear stress at A. Okay, so if you look at this example, you have this beam and then you have this cable support and this pin at A. Okay, so in order to solve this problem, you need to have, okay, or familiarize yourself with uh, the knowledge in your statics of rigid bodies. Okay, so first nato nga buhaton is draw the free body diagram. Okay, so you have this load 30 kilonewton, and then you have FB. So this is the support sa imong cable, and then you have two forces, horizontal and vertical, for A. You have AX and AY. Okay. Okay, so nga naman nga ang AX going to the left because yan counteract ang component there is a B nimo nga going to the right na forces. Okay? So that this structure will remain in equilibrium. Okay. So ang buhaton ni mana is first, using your knowledge in statics, apply a summation of moment at A. Okay? Para makuha nimo ang value sa imo ang kani FB. Okay, so pag sum nimo og moment ani, you have ang forces na involved is 30 and this one. So you have counterclockwise positive. So you have FB, pero ang component sa FB namin horizontal o vertical. Ang horizontal is 0 nga naman kay wala man na sa moment arm kay along man na sa diri sa imo ang A. So ang vertical component ra, so you have FB 4 times 4 over 5 times kani moment arm 6 minus clockwise minus 30 times 2 is equal to 0. Therefore, the forces sa B is just equal to 12.5 kilonewton. Okay, so nakuha na nato na. We need kuha po nato ni ang value ani. So we apply summation of forces along X and Y. Okay? So pag solve nimo ana, makuha nimo nga AX is just 7.5 kilonewton and AY is 20 kilonewton. Okay, so nganong kuha man nato ning AX and AY because mo man ni ang force nga experience sa imong pin, no? No, so ang reaction sa imong support mo na siya nagtulod sa mo na imong giload sa imo ang pin. So mo ni siya. So atong kuhaon ang value aning A. Ang pagkuha sa ana is you just get the square root of the square ani. So you have 7.5 squared plus 20 squared square root is just equal to 21.36. So mo din ni ang reaction sa imong A. Okay? So ang kung kuhaon na nimo, paana na siya. Paana. Okay? And then so mo ni siya i-load nimo sa imo ang pin. Okay, so if this is the bar, this is the beam, you have this pin support. Okay? So ang top view ana niya, this is mo yung beam, no? Top view ana niya, na-draw ka area that is subject to stress. Okay, kung mo man yung P nimo diri. Mo man ang P nimo diri. So naay duha ka area niya. Ang P nimo is just cylindrical raman na siya, na raman ni. Okay? So naay duha ka area ani nga subject to shear stress. Take note, ang i-apply ang support sa reaction sa imong pin is FA is 21.36. Okay, 21.36. Therefore, since duha man ni ka area, ang imo ang internal forces ani VA, ang imo ang internal force is pila man? Divide nimo 2. Okay? Okay, ang VA nimo is just FA over 2, which is equal to 10.68 kilonewton. Okay? So VA, therefore, unsa ang shear stress at A? VA over area. So ang VA nimo is 10.68 kilonewton over pila ang area. Pila ang diameter. Diameter is 20 mm. 20 mm. So, pi d square over 4. So, 20, pila na sa meter? 20.02 over 4. Therefore, ang imo ang shear stress is 34 megapascal. Okay? So, that's it. Huh? So, ang imong reaction sa imong kinahanglan man na sa resist ani. Mo ni ang imo ang internal forces. So, muna siya na-create sa imong ang shear stress. Okay? So, please practice solving daghang kayong problem sa book, no?